Yeah. 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 Stop it. Yeah. We don't get any audio. Yeah. Yeah. Stop it. Yeah. We don't get any audio. Yeah. Stop it. Yeah. We don't get any audio. We don't get any audio. Hello everyone. I'm not sure if... Oh yeah, you can hear me. Hello everyone. Ah, that's interesting. I'm not sure if... Oh yeah, you can hear me. Hello everyone. Ah, that's interesting. I'm not sure if... Oh yeah, you can hear me. Hello everyone. Ah, that's interesting. I'm not sure if... Apologies everyone, we are still having, looks like, some technical issues. They're trying to sort things out. Okay, I can see that you can hear well now. I think the only thing that's left is to get the video streaming well. Hello, everyone. Okay, great. You can hear me, and hopefully the stream will. Yeah, you can see my slides, but I think in the quarter of a screen. Oh yes, there you go. Perfect. Apologies everyone for the almost 40-minute delay, but this is the first day of a very big operation. So good that things are sort of all up and running now. So welcome to this 11th EuroVA workshop. And first time, this is a really unusual and extraordinary one, but from the comfort of your home. And then we are presenting from the comfort of our home. So we'll see how things will go. But we are really excited, especially now that things are sort of up and running. That's great. So at the moment, you will only hear me speaking, and Christian and Katarina will speak later on. And I'll sort of just give a quick introduction and open EuroVA 2020. So here is the here's the organizing committee. So this year it's Katarina Verso and myself are the workshop chairs, together with Michael Behrich as the publicity chair. You'll see him very active on Twitter and then getting links on our program up as soon as possible. And then Jörn Kohlhammer and Daniel Keim are the sort of still the steering committee of EuroVA. So I'll try to sort of be as quick as possible to save up some time for Christian's talk. But we are all learning that about the logistics of today. So as you know, as you're watching, so most of the sessions will be on YouTube. We're getting the YouTube stream handles on our program, but always the most complete and up-to-date resource will always be the main EuroViz Eurographics page. And then the YouTube channels are sort of for watching the live stream, and the Q&A questions and discussions will happen on YouTube and also on the Discord channel. So if you haven't already, make sure that you also join the Discord discussion channel and like interact with others. And on the YouTube channel, during the sessions, you'll be able to ask questions. On the Discord channel, you'll be able to ask questions, but also interact with each other and discuss the papers as they goes along. Apart from that, one important page is the virtual conference hub, where everything is in one place. You can go to the main Eurographics EuroViz page and go to the virtual conference hub, and you'll see all the links that you need. Yeah, I see. I mean, I'm on the side. I'm looking at the like the YouTube chat. So a link to the Discord channel is also on the main page of EuroVA. And also, if you go to the program, you will see a link to the EuroVA Discord channel. So just to give you a very quick overview of today, after this, we'll move straight into Christian's keynote. I think there will be a bit of delay, and then we'll eat into the first coffee break, but that's hopefully fine. And Christian will give us a keynote on visual analysis empowering the human in the loop. And then we will have 3 paper sessions. And then afterwards, we'll close. As usual, we'll have some coffee breaks between the sessions, and there will be a lunch around 12:30 Swedish time. So depending on where you are, you can have lunch, coffee, dinner, and sort of get some rest from the digital content. So first, the set of papers for today, and before we sort of talk about the session, here is a quick overview of how things went at EuroVA this year. So we had a broad set of topics that we called for: visual, interactive, and analytics methods, theory of visual analytics, and sort of techniques, application papers, and then we got a broad range of submissions again. The paper format has not changed: 4 pages plus 1 for references. We received 16 submissions this year, and we assigned 3 IPC members to each paper, and then got 3 reviews for each paper. And then all of that was discussed by the workshop chairs. We unconditionally accepted 12, and then 2 more papers went through a second phase. And in the end, we have a program of 14 very interesting, very strong papers. And here we would like to take the opportunity to thank our program committee. We have 40 amazing members of the program committee, which helped us to make these decisions, and then which helped to improve the papers a lot. So thanks to everyone here on this list for all your efforts and all your support. As I said, we'll have 3 sessions. The first one is visual analytics and methods and applications, and then we move on to the very popular topic of high-dimensional and temporal data. And then we have a very interesting session where we are looking at the intersection of humans and AI. The first session in the visual analytics methods and applications, we have a range of applications from spatial temporal events, spatial awareness, where we look at class awareness, type attribute visualizations, and dynamic network visualization. A very interesting broad range of applications. And then the second session, so we will have a series of papers from like the quality metrics, pattern visualization, to visual feature extraction, all the way to event sequence mining. And then the last session, it's looking at there are a set of papers that are trying to sort of look at how humans and AI can work together, or machine learning techniques can work together. Again, quite a set of interesting papers: coadaptive guidance, teaching and learning, a theory paper, and some interactive exploration and speech recognition, application of visual analytics in speech recognition context. And we have an interesting and very timely paper on epidemic, like to support the spread of analysis of the spread of infection. So we're looking forward to that as well. A very good and big development this year, and this is not only for EuroVA, but for all the EuroViz and Eurographics papers. All papers are open access. This is amazing. And then on the top of the EuroVA program, you will see a handle to the Eurographics digital library. You can go there as you listen to the talks. You can go and access the papers and download them and read them in full. And this is true for all the other papers as well. And without much ado, we are sort of moving into the best paper award, as we do every year. So what we have done this year, so we had for the best paper award, we had a short list of 3 candidate papers, and then we reviewed all the scores, we reviewed all the comments, we looked through all the sort of points raised by the reviewers, and this year we had a sort of a clear, I would say, one paper that stood out from the others. So it got a very strong praise from the others, and it was a very strong contribution. So without further ado, The best paper for EuroVA 2020 is Learning and Teaching in Corrective Guidance for Mixed Initiative Visual Analytics by Fabian Sperl, Astrid Geitler, Jürgen Bernhard, Daniel Keim, and Mena El-Asadi. So we congratulate the authors for this achievement. I mean, I would assume that there would be an applause at this stage if we were live, but with this, I would like to congratulate all the authors for this really strong paper. This paper was selected as the full paper for its theoretical contribution to how mixed initiative guidance could work in visual analytics systems, and it contributes with a strong and important position on how this coadaptive guidance could work. And then all the reviewers and the chairs find it as a theoretical an important paper, and also an important position paper to spark some very live, interesting discussions at EuroVA today. So congratulations again to the authors. Here is your digital certificate, and we'll hope that we'll get it over to you in some way sometime soon. So wait for an email from us. Right. So I see these virtual claps on YouTube, so that's great. So Fabian and colleagues, so like hear this virtual applause from the audience. Right. A few final news from 2020. One big development and one good development for this year is that EuroVA papers are now indexed in Scopus. This is thanks to sort of continuous effort from Daniel and Jörn. This will mean that there'll be an increased visibility for EuroVA papers, and this includes past and future EuroVA publications. So this is also a great development for EuroVA on the long run. And then just a very quick update about last year's ACM TIS special issue from EuroVA 19. We had a lot of interest in that special issue. It's still underway, but there will be a special issue published soon, like having a selection of some of the papers from last year. And we'll talk a bit more about that in the closing session later on. And one final thing, and one very important thank you to the outgoing EuroVA co-chair. Tatiana was my co-chair last year at EuroVA 2019. And this is normally done by Jörn, but he asked me to do this on his behalf. So we great thanks to Tatiana von Landesberger for running EuroVA for 2018 and 19. And this is again another sort of certificate that Jörn will pass on to Tatiana at some point. We know that Tatiana can't be here at this session, so we'll thank her again in the closing session, but just I wanted to sort of bring this up now. Okay, now with this we come to the EuroVA keynote by Christian Tominski, and then Christian will give us a talk titled Visual Analytics, Empowering the Human in the Loop. Most of you will know Christian very well, not only from his contributions to the field of visual analytics, not only from his books, but also from running EuroVA and being a very active member of the community. Christian has published lots of numerous books on visualization techniques and interaction techniques, like the visualization of time-oriented data, interaction for visualization, interactive, and finally, very recently, Christian and Hayden Schumann have a very recent book called Interactive Visual Data Analysis that was published recently. And today, we asked Christian to sort of give an overview of his research in an interaction and involving the humans in the loop, but also we would like to hear this tremendous journey they've had through the development of the book. With this, I would like to leave the digital floor to Christian, and I'm hoping that the transition will be just very smooth. And we are looking forward to hearing you, Christian, now.
Okay.
And just maybe before we switch over to Christian, like while Christian's speaking, feel free to post your questions on YouTube and also on Discord. And then during the talk, Christian will do maybe like we try to do a bit of interaction. So if you post your questions there, Katerina and I will be watching the channels and we'll pass the questions to Christian.
Okay.
Okay, so I'll stop sharing, and I'm guessing if you start sharing, Lisa will switch us to your screen. And I'll mute myself.
Let's hope for the best. Okay. Good morning, everybody. I got the honor to talk to you today. It's interesting for me to do this remotely. I prepared a slide deck for about an hour, but I think I have to shorten today because of the delay in the beginning. But I still hope that you enjoy the presentation, and I try to share the screen, and hopefully you can see this. Okay, Jagatai, can you see the slides? Great, then I will start. So the presentation today is about visual analytics empowering the human in the loop. And I think I don't need to tell you that visual analytics is about gaining insight into complex phenomena and based on like complex and large data. This is just a picture of what different kinds of data you may find out there.
Christian?
And, yeah.
I mean, we are seeing the interface, not the presenter mode.
Okay, that's not good. Then let me see.
Yes, better? Perfect.
Okay, sorry for that.
No problem. Great.
Okay, and visual analytics, the approach of visual analytics is to do this by computation, visualization, and interaction. And if you have a question that can be computed, well, go ahead and compute it. If the computation does not work for you, maybe you cannot ask the right question, or you just don't have anything that computes the answer, then you probably want to use visualization to maybe better understand which question you may ask at all, or to get an overview of what's in the data. But if a visual representation alone is not enough, then you probably want to add interaction so that you can look at the data from different perspectives. And actually, I think that many real-world problems are down here. So you need to have a combination of all these three things: computation, visualization, and interaction. And what I find interesting about these three ingredients of visual analytics, that they have kind of some historic roots, right? So Richard Hamming already said the purpose of computing is insight, not numbers. And this was in 1962. The very definition of visualization already spoke about unexpected insights and scientific discovery in 1989. And also interaction was always related, or has always been related, to analyzing data. Like this is a quote from Hutchins and all pioneering paper on direct manipulation, right? If you analyze data, you should be manipulating the data themselves. So these three things have existed for a long time, and now in visual analytics we do them together. And this brings us to the very definition of visual analytics, where you have the human and the computer working together, connected by a visual interface. And this loop is today the central aspect of my presentation today. And when we look at this loop a bit more closely, we can study what's inside this loop. And what I really like is Van Wyck's model of visualization, and I took the liberty to adapt it here to visual analytics. You have processes in circles and artifacts in boxes. And what you can see here is that data is transformed to an image based on a specification. Then the user perceives the images and generates knowledge. And via interactive exploration, the user adapts the specification, generates new images, gains new knowledge. And this is actually the loop that we are seeing. And this loop has to keep running to make progress in the analysis. And what we see here as well is that there are two parts operating together, the machine part and the human part. And now, in order to understand these things a bit more better, is like we look at these processes, the perception and the exploration, and also on the machine part, what the transformation is about. And in order to understand these better, we need yet more models. And the transformation is explained very nicely in the data state reference model, for instance. Like we know this as the visualization pipeline. This is a purely technical model that tells us how the data is processed via analytical abstractions, visual abstractions to image data, and then the user can control this process. But the user is not central to this model. This model is really about the operators and the data stages. On the other hand, the human side is nicely explained in Norman's model of the stages of actions and the level of processing. In this model, the human has some goal, and based on some goal, develops an intent, specifies a plan, and then executes the plan for interaction. On the system side, a response is generated, and this response is then perceived by the user, interpreted, and evaluated with respect to the original intent. And of course, this again shows us a nice loop where the human and the system work together. Interestingly, in this model, this model focuses on the human side, right? The system is only an abstract component. We do not know how the response is computed. But again, if we compute these two models, we may see how the visual analytics loop works. And the goal for today is to really have this loop tight and smooth. And to have this, directness of human control is a key requirement. We know this since the formulation of direct manipulations, and also fluid interaction asked for a tight and direct loop between human and computer. But directness is not easy to grasp, right? It's not easy to define what directness is. And to make this easier, to better understand what directness is, it can be helpful to look at directness from the opposite perspective and ask what are threats to directness. And I identify 3 threats to directness. One is spatial separation, temporal separation, and conceptual separation. And what I mean by this will be explained on the next slides. Like spatial separation is about the problem of having control and effect in different places. The figure here shows a typical example of a visualization tool or visual analytics tool where you have a view that shows the data in visual form, and then in the side or in a separate window you have controls where you can manipulate all kinds of parameters. What you see here is the spatial separation. You control something to the right, but the effect is shown in a different part of the window. The second aspect is temporal separation, and this regards the latency between the action and the effect. So if I change the color scale here, so like the visualization can be immediately updated, so there will be not much of latency. But if you, for instance, change the interpolation parameters, then it can take a while to recompute the interpolation, and so there's a discrepancy between the time where you initiate an action and the time you will see the feedback. And finally, there's also conceptual separation, and this is about the difference between what the user has in his or her mind and the technological model of the visual analytics interface. So like the implementation model is typically driven by technology. Like there are all kinds of algorithms with all kinds of abstract parameters and all like technical details that the user usually does not care about. And on the other side, there's the user's mental model that like is typically simple and smooth. The user is interested in solving the problem and not in how the tool that he's using is implemented. And so the important aspect is the represented model, which means like what is shown in the interface that really abstracts the details from the implementation model and makes the interface smooth and easy to run. So, and the goal for today is to reduce spatial, temporal, and conceptual separation to gain directness and to empower the human in the loop. And I want to do this based on 3 fundamental concepts, which I call, in the first case, in-situ interaction. We want to shorten distances for flexible information access. The second is progressive computation to reduce the latency. And the third is guidance to overcome conceptual hurdles. And guidance, we already heard, is an important topic. It's like the best paper for EuroVA is on guidance, so we will see something about this here as well. Okay, and it happens to be that these 3 points nicely align with the loop that I mentioned. In-situ interaction is centered on the human, the progressive computation is centered on the computer, and the guidance will then finally work on the interface. Okay, let's start with the spatial separation. Why is it interesting to consider spatial separation? Well, when people interact with systems, of course there are costs. Each of these steps in the Norman's loop are associated with costs, and spatial separation is a key driving factor for these costs. Like if things are far apart in the visualization, you have to move your head and look back and forth between things. If the interface is designed that you have to move your mouse or your hands greater distances, it's costly, of course. and this we want to reduce so that the costs are low. And when we look at traditional visual analytics interfaces, then we usually see this kind of what I showed earlier, that you have a spatially separated interface from the visual representation. The interaction is often heavyweight, and it's sometimes costly. What I mean by this is interaction and effect is not in the same place. By heavyweight, I mean that the interaction usually has a global effect, and the effect is also permanent. So there's no easy way to undo an interaction. And when you have functionality hidden in a deep menu hierarchy, then it's also difficult to perform. And due to the spatial separation, it's also difficult to understand. And what I propose is to go for in-situ interaction, which is integrated, lightweight, and efficient. The interaction and the effect are in the same place. The effect is local and transient, and the interaction costs are reduced. So like this in-situ approach is something that can be seen in relation to direct manipulation and also in the concept of fluid interactions as proposed by Alquist. And I want to show you two examples to illustrate what I mean by in-situ interaction. And these examples are lenses for graph exploration and also a specific tool for visual comparison. So lenses are a very versatile tool. Some years ago, we published a survey where we have all kinds of lenses that can be applied for visualization. And the nice thing about lenses is that they have this property of being local and transient and in place. And so what lenses do is they have a selection function. Usually you have a circular or a rectangular shape that you can move across your visual representation, and based on the position and the extent of the lens, a selection takes place, and whatever you select there, pixels, data, items, whatever, a lens function creates a lens effect. And this lens effect is then joined back to the original visualization so that you get a locally adapted visual representation. The schematic figure shows the basic properties of such lenses. And the effect can be, there can be different effects, but in principle there are three possibilities. You can alter the existing representation, you can suppress things in the existing representation, or you can enrich the visualization with additional information. And here are like three examples. The chrono lenses, for example, they do some alteration. So what you see in the background is a line chart, and when you apply the lens, a different chart with a different algorithm is generated and superimposed on the original visualization. The sampling lens is an example of a lens that does suppression. What you see here is a prior coordinates plot, and the lens just shows a sample of the original data so that you can see into the data where there are too many lines. And the third example here is the extended eccentric labeling from Bettini, where you have a kind of lens that you can move across a scatter plot, and you will get the labels that show the detailed information about the data points. What's interesting about this extended eccentric labeling lens is that it is not static in the sense that it always has the same size, but when you move the lens across a scatter plot, it automatically adapts its size to the density of the plot. So when there are very many points, the lens will shrink, and then when there are only few points, the lens will increase in size just to keep the costs for the labeling in check. So this is the basic idea of lenses, and what I want to show you today, and I hope it works, are graph lenses that help you gain insight or work with graphs. And you can see a URL at the bottom of the screen, so you are invited to try this demo as well, and I will try to switch to the screen so that we can do the demo together. Just a second. Jagatai, yeah, that's great. So what you see is a graph. You can zoom it. It's not a big graph, but just for the purpose of demonstration, it should be fine. And usually what you have when you do a node link visualization, you have a lot of edge clutter. And I've already activated the lens called the local edge lens. And you see the edge filters edges that just pass through the lens without a connected node being inside the lens. So when I move the lens to this node here, you see how the edges that just pass by this node are filtered out, so you can really see well what the connectivity of this node is. Now that you have figured out what the edges are, you may also be interested in what the neighbors of this node are. So what you would need to do, you would to zoom out and pan in the direction of these edges, and you have to do this for all these edges. So you really have to go to the information that you want to acquire. But instead of doing this, we apply a different lens effect. In fact, we combine the lens effects, the local edge lens, with a bring neighbors lens. And this lens brings the neighbors of the focus node to the lens, so that I create a local overview of the lens of the K neighborhood of the graph, so that I can really see what these neighbors are. Right, and I can do this for this node as well. And you see, yeah, there can be very many nodes being attracted, and this can lead to accumulation of the nodes in the center. And I can apply a third lens effect, a fisheye distortion, so that the nodes that are too close to the center are pushed a bit outside, so that you can better see these nodes. And this is something that really shows how you can use in-situ interaction to acquire a local overview of a certain focus area without doing heavyweight permanent interaction. And if I don't need this view anymore, I just dismiss the lens and I'm fine. Okay, back to the slides. Let me see where we are. Here we go. Okay, I hope this worked for you as well. And of course, you can try this anytime later as well. So this was the first example that I want to show you for in-situ interaction. The second is about visual comparison. Visual comparison is an important task in many analysis scenarios. And the particular example that I have here is a comparison of regions on a map. There's no particular data here shown on the map. In fact, it's random data, but it's fine for the purpose of demonstration. And now imagine you want to compare like a green area on the far right of the image with a green area on the far left of the image. And now you have to look back and forth between these areas to really figure out what the difference between the two is. Now assume that it's not just a color-coded map, but maybe there are glyphs on the map. and the glyphs show more complicated information, then of course the comparison will be very difficult. So the basic procedure, what you do when you compare is, first you select the objects that you want to compare. The second is that you carry out the actual visual comparison. And what you need to do as well, typically you need to understand the data and context. So when you have gained some insight about a local comparison, you want to check what is about the neighborhood, what is the context. And these three things can be nicely supported with in-situ interaction. And this can be done with a tool that I call compare ring. The focus here is on the ring, which nicely means comparing. And what this comparing tool does, it combines interactive and automatic methods to really support these three tasks. The first thing it does, it creates a dynamic rearrangement of the object that you want to compare. It supports a semi-automatic selection of the comparison candidates. And it supports navigation so that you can easily study the data and context. So here's first a schematic depiction of the comparing, and I try to explain how it works, and then we will later on look at a demo. So in the background, in monochrome background, you see some areas selected. This one, this one, this one, this one here. And the comparing creates a local arrangement of these regions. So it brings these areas into the slots in the ring. This already makes them easier to compare because they are closer together. We have the reduced spatial separation between these areas. Then it also provides an indication of where these areas originally came from. Like this is done with these arcs. The arcs show the direction where the region is originally located, and the width of the arc shows how far they are away. So like a narrow arc will show the region is close by, and a wide arc will show it's far away. And the color coding in these arcs shows a local difference. Right? In the picture, you see the mouse cursor in the lower left slot, and this is the region focused for the time being, and the color of the arcs shows a local difference with respect to the focused slot. So I can see that the reddish arcs, they have a bit higher value, and the bluish arcs, they have a lower value compared to the focused one. This is relevant when you compare, for instance, very similar objects where you cannot really distinguish between the colors. But I will show this a bit more detail in the demo. Okay, so and the key thing about the comparing is that the user does not have to go around and get all or collect all the information, but the comparing brings the information together that is needed for the task at hand. Again, I hope the demo works. There's tinyurl.com comparing demo. And I switch the screen sharing. And hopefully it works. Okay, here we go. This is our map. I already activated the comparing. I just want to illustrate the situation that you have without the ring. You see the map, and then you can drag the map around, but you would need to compare, like, how would you figure out what the difference between these greens is, right? And with the help of the comparing, you just bring all the information together, and then you see them close by and can compare them. And now what I did, I selected areas that are all very high data value, like meaning they are dark green, but I cannot really differentiate between the colors. And the local comparison now enables me to see what the local difference is, right? When I focus the different slots, the color of the arcs changes so that I can see and understand what the local differences are. And what else is possible with the ring? I mentioned that the navigation and understanding the data in context. When I'm focused on this region here, and I see these in comparison, I might be interested, how does the neighborhood of this one look like? Oh, well, I just click here and I'll be navigated to this region, and I click here and I'll be navigated to this region. So there's no need to do this manually. I just can use the interaction shortcuts to get there. Also notice the effect that when I navigate, the ring becomes more transparent, so that I can really see through it. As soon as I focus on the comparison again, then it gets more less transparent, so they can better see the regions that are in the ring. Okay, this is for the comparison with the comparing, and let's get back to the presentation. So this is what I wanted to show you, how you can enable flexible access to information directly where it is needed via in-situ interaction. And of course, there's many things to do in future work. For instance, in-situ interaction works nicely on one screen, but there's more work to get it work on multiple screens or across views. This is an interesting thing. Another interesting aspect would be to integrate several interaction modalities. What I showed you today was just plain mouse interaction, but of course it would be interesting to integrate touch or speech to really interact with these things. What else is necessary is an in-depth analysis of the costs that are associated with interaction. Right? We can provide these techniques, but it would be really interesting to compare how these things fare against traditional methods. And finally, I also mention toolkit support for future work, because all these interactions are like custom made, and it's not easy to implement them, because standard toolkits do not offer any support for this kind of interaction. So it would be great to have in-situ interaction, like toolkits that really help us do this in other visualizations as well. Okay, this would be the first bigger part of the presentation. Are there any questions right now? Or should we continue?
Christian, maybe we can continue.
Yeah, I have a short question in between, if that's okay.
Yeah, go ahead.
I find this in-situ interaction very interesting. What I'm wondering is that the examples that you show are, the lenses are quite intuitive as a direct interaction. I'm just wondering, what your take is on how much it increased sort of the need for training from the user, at what cost this type of interaction comes?
Okay, what I think is that it depends on the effect that the lens generates. I think it's like learning to use a tool. Of course, we are used to use standard widgets, sliders, buttons, and all this. But certainly we had also to learn them. And I think because the effect is usually local and it's integrated and it's lightweight, you can easily undo the things. I think it should not be that expensive to learn how these tools work. Of course, if you need to know what these techniques can do, what they offer to really be effective in using them. But I think that's in general the case. But once you get the hang of this, then it should be really easy to operate them, because the lenses are intuitive, and even the comparing is intuitive. Once you understand what the basic idea behind of this is.
Thank you.
Okay, then let's go on. Yeah, this was the first big part. I try to be a bit quicker with the other two parts so that we do not run too much out of time. The second thing was to consider temporal separation. Well, why do we need to do this? Because it has been proven that delays are really have an adverse effect on the analysis loop. It disrupts the analysis. And in the worst case, users even turn away when the system is unresponsive. For me, it's the worst experience when I do something with the system and I just do not know if it is doing anything at all or why I can't react anymore. So this is really a problem with the temporal separation. And this is also not something that is new. There's a really nice quote by Hare and Schneiderman that really say that to be most effective, the visual analytics tools must be fluid and flexible, and they must be in line with the pace of human thought. I really like this quote because it really tells something about why we need to have this directness in terms of time and latency. Yeah, well, the problem with the standard implementations is that these operators that I showed in the visualization pipeline, that they usually are monolithic. So they take the entire data and process it, and in the worst case, they even process the whole pipeline, and there's no chance that you can interact in between. So the problem is that in the first case, there's the latency that is the problem. The second problem is that these operators are usually black boxes. You cannot see what they are doing, and that's why you cannot understand what they are doing. And as I already mentioned, the control that you have over them is limited. And there's a lot of work on improving the situation by integrating progressive approaches. And the idea here is to generate partial results of increasing completeness and correctness. And this is done by basically two steps. The first is you subdivide the computations into smaller steps. And the other step that you can take is you subdivide the data into smaller pieces that are easier to process. And what you gain by this is three key advantages. First, the system is responsive at all times. Second, you gain transparency. You can look into the calculations. You can observe what the system does while it is computing. And as you have responsiveness and transparency, you also have the option to control or to intervene If computation goes in the wrong direction, just halt it and do a different, try a different way. If it goes into a promising direction, let it run, but maybe leave out the context or something. So this is really an important aspect, that you try to have this responsiveness, transparency, and control. But in order to get that, you really have to think about how to implement the system. And this is also something that is not trivial. I mean, there are many conceptual aspects to consider to get this partial results and to have trustworthy partial results and all these kind of things. And on the implementation side, you really have to think about how you can do this so that you really gain from this progressive approach. And what we did several years ago was to propose a multi-threading architecture, where the key idea is that the human directly interacts with the control thread, and the only purpose of the control thread is to distribute tasks, and the actual computations are done with processing threads. And what is important about this processing threads is that they can be terminated early, right? If you do an interaction, the control thread says, okay, let this computation run on the processing thread, and another interaction comes in, which invalidates the already running computation. Then it is important to be able to really terminate this thread and generate a new one with an updated request. And another important aspect of this architecture is that the visualization works with layers. Layers not only in the graphical sense, but in a conceptual sense, meaning that the layers are the subdivisions that in the end, when being accumulated, generate the complete image. And there are three different types of layers. Incremental layers, which like show subsets of the data. Semantic layers, which show or which separate the data based on their inherent semantics. And there's also level of detail layers, which like get increasing precision or levels of accuracy. And with this general model, you can really implement a progressive visual analytics system. And what you gain by this is, I just want to show this comparison with the standard approach. What you usually have when you, in the standard visualization pipeline, you send a request to the computer, and the computer processes all the data and gives you a complete result indicated by the black box here in the bottom. And you have a latency between when you can interact again and when you see the visual feedback. On the right-hand side, we see the progressive approach. You send a request, the control thread initiates the processing in the background, but returns the control immediately to the user. So the interaction latency is very low. So you can really interact again if you would like. Actually, it does not make much sense to interact because you do not have any feedback, but you will soon get the first feedback. A partial result will be provided to you. And based on that, you could really think about, does the partial result already tell me something about the data? Do I need to interact again, or can I wait until the computation is complete? And the user will get increasingly detailed results until the final complete result is there. And while this happens, the user can really understand how the computation evolves, what is generated, what are the intermediate steps. And so the user can understand what's going on. And this progressive computations can be applied throughout the pipeline. We can do progressive data processing, we can do progressive visualization, we can also do progressive display in the sense that we can use JPEG 2000 encoded visualizations that progressively transfer image data to the mobile client, for instance. But I only want to demonstrate two things here, a progressive graph layout and a progressive network rendering, to show some illustration of the benefit of progression. And I think I don't need to talk much about the graph layout thing. This is something that is quite standard, that you start with that you generate a layout progressively, in the sense that you incrementally update the node positions based on some force calculations or some other calculations, and the user can observe how the layout computation evolves. And this is an example like 747 nodes and about 60,000 edges, and you can observe how this layout is generated, which is quite nice. Another thing is the other example that I want to show is about, I hope you can see the video. So what we see is a globe visualization with a climate network with about 7,000 nodes and more than 200,000 edges. And so in this case, there's no need to compute the layout because the node positions are clear. However, the bottleneck is here is to get the visual representation from the CPU to the GPU. Right? You have to create a sphere for all of these edges, and you have to create curved lines for the edges. And so this is very expensive. And in the progressive implementation that we just saw here, I try to share another screen where we can see the video again. Just a second. Share. Can we see the video? Great. So this is a cesium virtual globe, and what we see here, first the nodes build up, there's semantic chunking. First the nodes, then the edges, and within the semantic layers, there's incremental chunking. So we see that first the nodes come in subsets, and then the edges come in subsets, and until the complete globe is filled. What is nice about this, you cannot see it, but you can interact at all times with the globe. So you can rotate it, and you can start looking at the data while the visualization builds up. And if you would not have the progressive approach here, you would have to wait for about a minute before you see the first picture and before you can interact at all. So this again demonstrates the usefulness of going progressive. This is just a screenshots just in case that the video did not work. Okay, so I hope you are convinced that it is useful to address temporal separation, to get timely visual feedback, and to have better control and insight into what the computations do. And again, there's a lot of future work that could be addressed in the future. I think important things are guidelines and strategies for chunking data and how to subdivide the processing best. There are several examples out there, but we do not yet have a complete understanding of what works well in what circumstances. The second thing that I find interesting is to make use of the new capabilities of programming languages. So C++, for instance, has coroutines now. generators in JavaScript and general asynchronous computing and promises and all kind of these things. It would be interesting to really make use of them to support progressive computations better. And so these are aspects that are relevant for compile time. So when we set up progressive computations. And there are also interesting questions to ask to improve the runtime. So while progression is used, for instance, it would be interesting to investigate methods that really help determining and communicating the quality of the partial results. So that's an important aspect, so that the user can know how reliable is the partial results that I currently see. And we also need to develop strategies for reacting to user interactions, meaning, like, what do we do when the user interacts? How can we pre-compute or pre-fetch results, anticipate what the user may want to see next, caching, and how to keep track of user interactions in a progressive scenario. I think that's very interesting to think about these things. Okay, this was the second part. And are there any questions right now? Or should we continue? We continue. Okay, this is then the final part of the presentation. This is about guidance and reducing the conceptual separation. So why do these things pop up? When we have a complex data, of course, we have also complex tasks. And in order to solve these complex tasks, we have probably complex workflows and use non-trivial tools. And this poses a lot of questions to the user. What algorithm should I use? Where should I look in the visualization? Which parameters are the right? What should I set there and what should I set there? And if these questions cannot be answered by the user, the analysis loop simply stops. So, and we cannot make any more progress in the analysis. I return to the model that I showed initially, and we can see each of these components is somehow associated with the question. And this is not all. There can be many more questions. And this can make visual analysis a complex endeavor. And the idea of guidance is to support the user in making progress in the visual analysis and to provide support when it is needed. And there's a nice definition of what guidance is. Guidance is a computer-assisted process that aims to actively resolve a knowledge gap encountered by users during an interactive visual analytics session. So the important aspects here is it's a process, so it's not something that is static, but it's something that adapts to the analysis situation. Guidance is about solving a knowledge gap, so there is something that the user does not know, and we want to help him. And the analysis is interactive. So there's an exploration loop going on, and this is what we're talking about today, keeping the loop going. And there's several aspects about guidance. First of all, the knowledge gap, the input, what's the information that you use to provide guidance, the output, and the guidance degree. I will briefly talk about these on the next slides. First, the knowledge gap. This is the question, why isn't guidance needed at all? And there are two different types of knowledge gaps. The first is the target. So if the user does not know what to do or what to ask or where to look. And the second type is the path. So the user might know what to do, where to look, but he might not know how to get there. So that's the difference between not knowing the target or not knowing the path to the target. And path and target can be in different domains, like data, task, methods, users, and infrastructure. When I talk about the data domain, I may not know what to focus on. The what question applied to the task domain might be like, I do not know what task to do next. And similarly, I might not know what method to apply. So this is not the only thing. You may also have a situation where multiple users work collaboratively to solve a problem. And there you may also ask the question, who should be working on a task in order to come up with a good result, right? So you can have the target or the path knowledge gap in different domains. Even in infrastructure, should I look at the data on a big screen, or should I look at the data on a smaller screen? This is for the knowledge gap. And then there's, of course, the question of what information we can use to help the user overcome the knowledge gap. And first of all, we can derive information from the data themselves. And we can also use all kind of information related to the visualization or the transformation process. We could analyze the images, or we could look at the specification that we use to generate the images. And we could also go back to domain conventions or user knowledge, or analyze or look at the analysis history to really provide guidance. And there's the output question, and closely related to that is the degree of guidance. How can a guidance be conveyed, and how much guidance do we provide? Guidance can be conveyed in different ways, and we identified, like, we can apply visual cues that help us indicate something. We can provide options to be selected easily, or we can do automatic specification, where the guidance autonomously sets a certain specification parameter, for instance, to improve the situations to help the user make progress. And these different output options are closely related to the degree of guidance. For instance, visual cues would be a low degree. They are just indicating something. They are just orienting the user to something interesting. There's no preference about things that to which the user is oriented. When we provide options, we have a certain preference. And then in this sense, we are directing the user to some aspects. And finally, when we have a high degree of guidance, we prescribe, so to say, the next step without giving the user many options to do an alternative. So these are the basic aspects of guidance. The knowledge gap, the input, the output, and the degree. And when we put all these things together, we will end up with a complicated model. We start with Van Wyck's model that I showed several times already. And now we attach guidance to this model. And what we end up with is, as I said, a complicated model. But we can nicely see that guidance is something that operates in parallel to the original loop. We have the guidance as a process that draws from several inputs: the data, the image, the original specification. It draws from the history that is generated during the exploration, and it draws from domain conventions, for instance. And on the output side, guidance may prescribe by directly influencing the specification of the transformation. It may orient by providing visual cues that the user can perceive in order to make progress in interpreting the visualization and gain more knowledge. or we can provide options that direct the user and that the user can directly choose or select during the exploration. So this is our take on a conceptual model of guidance. And of course, it is complicated, but on the other hand, it nicely shows how guidance can be attached to the standard visualization or visual analytics loop. Of course, this was quite abstract. I also want to present a concrete example of how guidance may look like. And the example that I chose was is navigation recommendations for hierarchical graphs. So what is a hierarchical graph? It's a graph that has been clustered hierarchically. And when you navigate such graphs, you have two different options for navigation. You can zoom and pan horizontally, meaning you stay in one level of abstraction of this graph. Or you can navigate vertically, meaning that you can expand or collapse certain nodes in order to get to a different level of abstraction of the graph. So, and the question is that the user may ask himself or herself, where should I go next? Should I pan in this direction, or should I expand this node, or should I collapse this node in order to get an interesting view of the data? And we aim to support this by providing navigation recommendations. And the idea here is to collect recommendation candidates in the first place. What we do here, we consider the current focus of the user and then look in the neighborhood of this focus to acquire candidates. And we look in the neighborhood with respect to the graph structure. But we also look in the neighborhood with respect to the graph layout. So this is a different neighborhood. And we could also look in the neighborhood with respect to the data attributes. Like the red dots here indicate what the current focus is. And the green nodes indicate the neighborhood that we would consider as candidates. And we see that for different aspects, graph structure, layout, and attributes, we will get a different neighborhood, which kind of nicely integrates all the different data properties that we can have. And the second step is to rank and select candidates to be recommended based on a degree of interest function. And this interest function integrates several components. First of all, the distance to the focus, then an a priori interest that may be defined in the domain. The user can specify their own interest as a separate component. And there's also a notion of a visited state, kind of history, so that we keep track of what has already been in the visualization. And when the user has seen something already, it becomes less interesting, and it's less likely that it will be recommended to be navigated to next. So these things are combined in the degree of interest functions. The final question is how we can convey the guidance to the user. And what we do here is two different things. For horizontal navigation, we use wedges, which is a known off-screen visualization technique that indicates targets that are off-screen. The wedge also shows the components of the degree of interest function so that the user can understand why a certain target is recommended. And we use pulsing rings to indicate suggested vertical navigation. Outward pulsing rings are for collapsing or for expanding a node, in what pulsing rings are for collapsing. This is just to give you an impression of how these guidance things work. And What is important is that the visual cues must not interfere too much with the original visualization. Okay. Again, guidance is there to assist the user and to overcome the conceptual hurdles and to minimize conceptual separation. There are many questions to ask. The recent article, you can find the details about this. There are many open questions regarding guidance. How can the knowledge gap be inferred? When is the right moment to provide the guidance? What is the right degree of guidance, and so on and so forth. Okay, and so with this, I basically completed the loop. What are the main takeaway messages for today? I would say go beyond the standard visual analytics graphical user interface and strive for in-situ interaction. Consider progressive computation to reduce latency throughout whatever you implement. And finally, think about how to assist users during the analysis process. And well, there are also bigger things to consider next. For me, still an important aspect is the integration of computation, visualization, and interaction. Make algorithms work progressively. Integrate in-situ interaction, and finally, like integrate natural interaction, and also like obtain true mixed initiative visual analytics, where the user understands the data and the processes, and the user can also feedback his knowledge and insight to the system, and the computer can learn from what the user inputs to the system. And on the other hand, the computer can also guide the user to make the program, make progress, to really have this mixed initiative. And this is also reflected in the, I think, in the best paper is exactly in that direction. So personally, I'm very much excited about the new technology that we can use for visual analytics, and I would like to see more about this, integrating large displays, integrating multimodal interaction, immersive analytics, big screens, and really heterogeneous multi-display environments. I would also think that we may go a bit further with respect to the tasks that we solve in visual analytics. Usually we do data analysis, but we may also need to do data editing or data wrangling, and finally data curation. So when we understand the data, we may also understand what should be changed about the data, and usually what we have to do, we have to switch tools then. And so I would propose that we integrate editing functionalities into visual analytics tools as well. Okay, and with this, I'm at the end. I talked a lot about the human and the loop, and I'm sure we will hear more about the machine side during the paper presentations. And yeah, a big thank you to the organizers for inviting me. Many collaborators that helped creating the papers and all this, and also thank you to the audience for listening. And a very special thank you to Heidi Schumann for being a great mentor and for writing this nice book with me together. Many thanks. Are there any questions?
Hi, Christian. Thank you very much for this really interesting keynote. I mean, I don't know how to sort of transfer the applause, but yeah, there'll be some icons of applause. So thank you very much again. Yeah, they are coming on the YouTube channel. We do have some questions that just came in. And like the first question, maybe like a very practical one, and the question is about how long the development cycle is for a system like that. So what's like, how long does it take you for these types of projects to get them up?
Yeah, I totally agree, and I know from my own experience that implementing these systems is costly, right? And especially when you really go into the details about interacting and making things smooth and integrating things so that the user can work with them nicely. And I really think that this is a critical issue, because not many people have the time to invest to really smoothen or optimize the visualization or the visual analytics tools. And that's why I would really love to see toolkit support for these kinds of things. Right now, it's all handcrafted and manually customized, and it's expensive to implement. That's totally true.
I mean, that interestingly relates to another question that Michael raised. So do you think we need a special language for visual analytics, or an environment that we should aim?
So I'm not sure. I think it would definitely be nice to have such things, but I'm also a bit skeptical if we have simplified languages for us. For instance, we can create visualization using the new declarative things, right? But when we do this, we are stuck within what the grammar allows. We cannot go beyond that. So at some point, when we do research on this, we probably need to invest a bit more than just creating end-user tools. But I think when we do science, then we really have to do things manually to go beyond what is possible already. But for end-user development, such tools would be definitely helpful. And I see nice conceptual things in progressive area, and also there's also some, I think this P5 paper, which is has a declarative approach to progressive computation. But also computing languages, the programming languages, they offer nice new features which we have not fully considered yet, I think.
Yeah, I guess this the what Vega and VegaLite has done even in the Python world now for making visualizations available for a wider audience. Maybe we think of a similar approach in visual analytics, right?
Yeah. Again, I think it depends on what we want to do. When we want to allow domain experts implement their own tools, they definitely need this toolkit support. When we want to advance visual analytics as a field itself, then I think we still need to do a lot of manual implementation to really be on the front.
Yeah, thank you. There's a very interesting question from Sylvia, and you can imagine that the question involves guidance coming from Sylvia. And her question is, can guidance be applied or used to improve in-situ interactions and progressive computations? And if so, how do you see guidance having a role in that?
Yes, sure. Guidance is definitely worth at all levels. And a particular example that comes to my mind is about gestural interaction. There's a tool, gestural interaction is about drawing a gesture on the screen. And of course, you need to know the alphabet, what gestures you can draw on. There's a nice tool called Octopocus, which provides hints while you are starting to draw a gesture, what possible ends the gesture may have. So while you're doing the interaction, there is guidance in supporting you to completing the interaction. And then this is a nice example of that guidance. Sure, works for interaction as well. And the gesture is in situ, so it works for in situ interaction. And I would totally say yes, guidance will help for in-situ interaction, yes. And also, like the examples that I show, they do not integrate guidance, but I can easily imagine integrating visual cues that help me perform the interaction. And this also relates to what Katerina said in her first question. Is it easy to learn these things? And sure, when we provide guidance, it will be easier to learn.
Yeah, and I had this sort of question about how to sort of make these systems adapt to different users with different expertise levels. And I think that point that you're making now is like guidance is maybe the key to sort of adapting to different users with different backgrounds and different expertise, right?
Yes, this is one aspect. I have to say the mixed initiative and really mining user interaction work well when you have a larger user base, right? This is something, it's a delicate thing. When you have visual analytics as an expert tool with a handful of experts working with it, you probably cannot learn too much about what the user is doing. So in that case, you would really need input from the user, active input, that the user says, okay, I'm not very familiar with this. Can you help me, or something like that? Mm-hmm. But if you have a larger user base, then you can certainly learn what other users have done, or where they could not make progress as quickly as the system might expect it, and then can automatically guidance can jump in.
Great, thank you. I mean, there's one more question, and then maybe we can then wrap it up, from Mark-Jan Buledo. And Mark-Jan's question is whether you think that in-situ interaction experiences are less common because they are more difficult to conceptualize and also to develop.
Yes, totally true. First of all, you need to have a problem that you, so the things that I showed today, the examples, you can do this with standard widgets, but then it will be cumbersome. Like, I don't need the lens to explore the edges or to visit the neighbors. I can do zoom and pan, but it's more costly. So in the first place, you have to think about the problem and then think about how you can solve it with an alternative approach. So this is at least how we came up with the lenses, and also the coppering, which essentially does the same. It brings the information to the user. And designing this is a longer process. It's not that you think about it and it pops up and then it's there. You have to implement it, then you test it, and it does not work as you expected, and you may need a different design. And this makes really developing these things expensive. But I think as soon as you have the tool, it is really useful. And of course, then it's the question of really using it as a tool. I think the person who invented the hammer really had a hard time coming up with the idea and really crafting it. But now it's a tool that everybody uses. And also the standard graphical user interface is not something that popped out of nowhere, but it was carefully designed over years. And now we use it as a standard tool. And so maybe in a few years, we can say that in-situ interaction and techniques that work like in-situ interaction are standard tools for us. But for the time being, it's, of course, expensive to conceptualize and to really implement these things.
Yeah, I think it's on us as researchers to keep working, right? Thank you very much, Christian. I don't see any more questions coming, and also sort of in order to make up some of the time that we lost in the beginning, we thank you very much again for this really interesting talk. I think you brought up lots of interesting points and lots of interesting future directions for us to think about. And I'll sort of encourage everyone to be active on Discord. Christian is there as well. All of us are there. Like, bring up any discussions on the Discord channel, on the EuroVA Discord channel. And the next thing for us is that, I mean, there would be a break normally, but we will now switch to the second session. So which means that this live stream is sort of coming to an end, but there's another live stream starting in a few minutes as soon as we set up. And then the link to that is on the 2020 program. And I see that Michael is sort of getting the link also on the YouTube chat. So thanks everyone for joining. Thanks again, Christian, for the talk, and we see each other on another YouTube stream.
Thank you very much.
Bye. Thank you. Bye. Bye.